now.
Okay, so we are on chapter 17. I'm talking about asteroids. There was a cool game called Asteroids when I was y'all's age. It's one of the first video games. This, what's that? You want to turn the lights off?
Yeah.
This is a big asteroid called Gaspra that was photographed by the Galileo spacecraft. Y'all remember the Galileo's 10 points if you can tell me what was the main mission of the Galileo spacecraft. It photographed this asteroid on the way to its mission. What was the main mission of the Galileo spacecraft? Yes, Peach is correct.
That's my team.
Look at y'all knowing stuff.
I just...
The Galileo spacecraft had a main mission. Going.
Hang on. I'm bringing
Wait, no, I don't.
I'm bringing the odds.
Or,
Blue correct.
yeah, hey, that was
Purple correct. Anyone else?
Okay. Okay.
Green correct. Anyone else?
So this is chapter 7.
It's to study Jupiter. So this spacecraft on the way to Jupiter went through the asteroid belt and took pictures of asteroids as it went by. This is one of the asteroids it took a picture of. Gaspra, yes.
Wouldn't that be like dangerous? What if it hit one?
Would be, but you know what? This is a good question you raised. The asteroids. Can I answer your question in just a minute?
Yes.
Okay. So this is an asteroid, asteroid 2004 FH, and this is what it looks like going through space. The way they find asteroids in space is they take what's called a long exposure. Have you ever heard of long exposure photographs? They take a picture of the night sky and they leave the aperture open for a long time. And then they, if they see a streak going across, that means there's something moving across the field of stars that they're taking a picture of. So they'll look for these streaks, and if they find a streak, that's an asteroid. And then what they can do is they can take other telescopes and they can look, they can calculate from that streak how fast the thing's going based on how long the exposure was.
Is that a shooting star that like passed through?
That's a good question. That is a satellite that goes through like that. That's a satellite in Earth's atmosphere.
I didn't know it was a satellite.
They know it's a satellite by where they were taking the picture.
It's going so fast.
Well, yeah, because this is a long exposure. They're following it for a long time. Or that's a long. This is not a long exposure. This is a video. This is a videotape of that asteroid moving along. Asteroids do not glow on their own. Asteroids reflect light from the sun. So all the stars, those are stars in the background that are making their own light. But that one right there is reflecting sunlight.
Wait, did you
And
say
so is the satellite that goes by. That's
is that
reflecting
sped up? You
sunlight.
said?
Yeah, this is sped up.
So they reflect light, you say?
Yeah, they reflect light from the sun. They don't glow on their own. It's just a big rock in space floating along. The only way we can see it is because it's reflecting the sunlight. Same way we see the moon. The moon's not glowing on its own, it's reflecting sunlight. So to us, that would look like a star. If we just saw it sitting there in outer space, it would look like a star. But you can tell it's an asteroid if it's moving. See what I'm saying? Know what I mean? Did y'all feel? So, these are where asteroids are found. Every little dot is an asteroid. And there's Sun and Mercury and Venus and Earth and Mars. By the way, some of y'all don't know the order of the planets, I noticed by your essay. Here's how to remember it. My very educated mother just, what's after? Just served us 9 pizzas. Neptune, Pluto. My very educated mother just served us 9 pizzas. Those are all the planets. They dropped pizzas off, so you got to find some
Nachos.
Nachos just served us nachos. So, here's the asteroid belt between Mars and Jupiter. There's Jupiter. So between Mars and Jupiter, as that Galileo craft was going from Earth to Jupiter, it went through the asteroid belt. So you asked, isn't that dangerous? Couldn't it hit some of these asteroids? It could, but this is not to scale. Asteroids are really small. And the asteroid belt is not like you see on like Star Wars when they're flying through asteroids and they're ducking behind one and there's somebody shooting at them and there's all these asteroids around. That's not what the asteroid belt is like at all. The asteroid belt is an asteroid here and a whole bunch of space until you reach the other asteroid. As a matter of fact, if you were standing on one of the asteroids looking around, you wouldn't see another asteroid, even in the asteroid belt. They're that far away from one another. If they were close together, like in Star Wars, well, they'd hit one another, and they'd break one another up, right? It's not like that. They're really spread out.
If you try to stand on an asteroid, does it have any gravity to it?
It does. It's got a little bit of gravity.
Yeah.
And it's got more than you, so it would hold you on there. But if you jumped it off, you could probably jump all the way away and go out into orbit away from the asteroid. It depends on the size of the asteroid. Some asteroids are small, some are big. This one right here, Gaspra, is bigger than the island, than St. Simon's Island. So this is a pretty big rock.
Oh my god.
That's a big rock.
Wait, what?
Looks good.
Bigger than what?
This asteroid Gaspra, that's like 30 kilometers long.
Wow.
Yeah, it's way bigger than St. Simon. That's bigger than the one that killed the dinosaurs. That hit the Earth.
That's scary.
That's a big old rock.
And that's out there?
Yeah,
It's floating around in the asteroid belt.
It's not going to come
What
towards
are
us.
those balls?
No, it's that one's not going to hit us because that one's out here.
Yeah.
But it could take
Was
It could what?
I was about to say it could take out, but when you said it's up here, I was like, never mind, I can't really.
It could. It
Go off of its thing and
it
get
could hit some other asteroid potentially, and that slows it down, and then it starts falling into the sun. And that's what some asteroids do. Sometimes you have asteroid collision. One speeds up and one slows down. The one that speeds up might fly off out into space. The one that slows down might fall into the sun. And then you have what's called an Earth-crossing asteroid, or a potentially hazardous asteroid, which is called a PHA.
How did the asteroid that destroyed the dinosaurs, like, come into Earth?
It probably fell out of the asteroid belt and started orbiting around the sun, and eventually the Earth hit it, or it hit the Earth. Yes?
When the asteroid hit the Earth and the dinosaurs died, when life came about again, why did more dinosaurs not?
Well, it didn't. The asteroid that killed the dinosaurs didn't kill everything. It killed the dinosaurs,
Yeah.
and it killed a lot of creatures, but it didn't kill the mammals. The mammals like mice,
Biology.
they weren't killed. So they were hiding in the ground from the dinosaurs. Well, when all the dinosaurs died out, the mammals took over. And they grew bigger, and they grew to huge sizes. Some of them big as elephants, and mastodons. They grew big like the dinosaurs were. So the dinosaurs were in no position to take over because now the mammals had taken over. So the reptiles that didn't die out were little lizards and stuff that are still running around. And the birds. And the birds did very well, and that's what's left of the dinosaurs, the birds. And they're doing okay. And some of them grew to get to big sizes again. There were some birds, ostriches and things like that. There were some birds even bigger than ostriches that have gone extinct. So anyway, back to this. There are a lot of asteroids out there, but this picture makes them look like it's real dense and there's no way you could fly a spaceship through there. That is not correct. There's huge amounts of distance between that. And if you were to shoot a spaceship towards Jupiter, there's a very little chance it would hit an asteroid. although those ships that they do launch they do know what asteroid, they have charted most of these asteroids and know how they're orbiting. And so they know, make sure they'll miss those things. So here is a typical, there's different types of asteroids out there. There's some called near-Earth asteroids. And there's some called PHAs, potentially hazardous asteroids. A near-Earth asteroid has an orbit that takes it near the Earth's orbit. So look at the Earth's orbit as green. And Venus's orbit is right there, inside of the Earth's orbit. And there's Mercury's orbit. Guess what that is?
The sun.
Sun, Mercury, Venus, Earth. There's a near-Earth asteroid. It's an asteroid that actually orbits close to the Earth. There are some of them that do that. And often we'll fly spaceships out to take pictures of them. We call them near-Earth asteroids. But they aren't going to ever hit us because they're in an orbit that's further out than ours. But sometimes some of them are called PHAs, potentially hazardous asteroids. They're on an orbit that crosses paths with the Earth. Look, right there they could hit us. And right there they could hit us. There's two places in the orbit where they could hit us. And so we call those PHAs, potentially hazardous asteroids. They are also called Earthcrossing asteroids. And there's about 4,000 of them out there that we know of that could hit us. But we can mathematically calculate when they cross our orbit, and we can see that some of them will never cross orbits right when we're crossing, so we don't have to worry about them. But there are a few of them that might come close to hitting us in the future, and we got to worry about those.
And when you say future, do you mean like future, like our future, or future like nowhere, like what will be dead?
Usually it's millions of years into the
That's
future.
what I was.
There is one, though, that could hit us in the year 2880.
Oh, man.
It's a half a mile wide.
I think we're
The one that killed the dinosaurs was 8 miles wide. So this one that's a half a mile wide, it wouldn't do the damage that that one that
You
killed
think
the
it'll take out a
dinosaurs.
continent?
But it could take out a city. That's a half mile wide, could take out a city. So we're going to want to try to deflect that thing, because it might be a pretty big impact.
Oh my gosh.
Do you want to see what an impact would look like?
Yes.
Yes.
If it were hundreds of miles big?
Yeah.
An asteroid hundreds of, like way bigger than that Gaspro one? If it were the size of like a small planet?
Yeah.
just knock out.
Wait, does that exist, Mr. Ross?
Yeah, they're out there. There's one called Ceres that's
Yeah.
huge.
That's
It's the biggest asteroid in the asteroid belt. You want to see what it would be like if that thing hit us?
Would it just?
Yeah.
I'll show you.
Didn't you say you were going to show us a video of like?
That's it.
Like what? Do you want to finish?
I thought it was like you were going to show us a video if like all of like the super volcano went off, right?
Oh, I don't have that video.
Okay.
Yeah. But I have one if we got hit by an asteroid the size of
Let's
Ceres.
see it.
And this is
Ceres
it.
never hit us.
First, I think it's like, that's scary.
It's not in the
Pretty
orbit.
sure our change. I don't even
2012.
know.
That'd be a glimpse. That'd be a quick way to go.
Let's shoot paper like that.
2012.
It's on fire. It's be done.
I feel like it would. Maybe it's still normal.
Oh my gosh.
Head straight for
That's terrifying.
a massive asteroid from outer space.
Sorry, hold on.
Pardon it not to a massive asteroid from outer space headed straight for Earth. It's as large as the one that impacted over 4 billion years ago. This computer simulation has been made with a scientific advice of geophysical experts to show the effects if the impact were to happen today. The asteroid's diameter is larger than the main island of Japan. Even though it is moving at over 720,000 kilometers an hour, that's almost 450,000 miles an hour, the asteroid appears eerily slow because of its size. The actual impact happens in the Pacific Ocean, just under 1,000 miles south of Japan.
It's always Japan. They always give me credit.
by what is called the crest tsunami. Even the deepest part of the Pacific Ocean looks like a thin film. The size of city blocks are hurled into the air. The entire Japanese archipelago is disintegrated, as is some of the Asian continent. The shattered remains are hurled out into space way beyond the atmosphere to bombard the Earth with deadly intent when they re-enter. 7,000 meters, 23,000 feet, the rim of the crater is higher than many mountains on Earth today. The size of the crater would be a distance of 2,500 miles or 4,000 kilometers. And this is just the start.
When an asteroid hits the surface of the Earth, the material is heated up to temperatures that get up to the point of, say, 4,000 to 6,000 degrees centigrade. This is as hot as the surface of the sun. When an impact hits, it's not just the crater that forms, it's not just the area where the impact occurred. It's all the heating that's created in the atmosphere and around it. So heat really is the killer.
Moments after the impact, rock vapor, the temperature of the sun, begins to engulf the world. Could any life at all survive this impact? Immediately after the impact, the rock vapor rises up from the crater in a dome, then spreads out in all directions across the globe. 3 hours after the impact south of Japan, the expanding wall of vaporized rock reaches the mountains of the Himalayas. The perpetual snows are instantly evaporated. Soon the wall of fire reaches the Amazon, the furthest distance from the point of impact. The forest spontaneously combusts even before the rock vapor arrives. Just one day after the impact, the entire planet is covered. Every living plant or creature is vaporized. It's been estimated that this vapor would cover the entire globe for almost a year. It would be as if the sun had come to Earth. The ocean would start to bubble and boil. And as the water evaporates, the oceans will drop at the rate of 5 centimeters or 2 inches every second. Even the salt deposited on the ocean floor vaporizes, and then the very bottom of the sea melts. Nothing is left untouched. One month after the impact, the surface of the world has been sterilized. The oceans have vanished. All that remains is the superheated bedrock. It is thought that an impact like this happened 6 times in the violent past of the Earth's history.
How did it rebuild
go on in that video. That I've seen that whole program. It's
So,
like
this
it's an
could
hour-long
never-
program.
This could never happen in our lifetime.
It could if we got hit by an asteroid like that.
Well, you said they detect that.
Yeah, hopefully we could knock it away before it hits us.
What if it's on the other side of the sun?
So yeah, they
That would surprise me.
there wouldn't be much survive if something that big hit us. But what they say in that program is there are bacteria living down deep in the ground under the surface that have actually survived events like that, because that sort of event happened billions of years ago when the Earth was first forming. It happened lots of times because the solar system was full of these asteroids and they were absorbed by the planets. So this was happening. They think it happened on Earth 6 times. They have some evidence showing that probably happened 6 times. So the entire surface, everything was killed, but there were bacteria down deep in the ground that survive and come back out and repopulate once everything settles down. Yeah.
You know, in the video it said it would take a couple hours for that like magma stuff to spread.
Yeah.
When the asteroid first hit the Earth, would you feel that everywhere?
Probably so. Yeah.
Like how?
It'd probably be a giant earthquake.
Like everyone would die.
I don't know. Depends on how big the asteroid
Would
is.
there be tsunamis?
If the asteroid was smaller than that, it wouldn't be as bad.
Don't asteroids hit our planet now? They're just small.
They're a lot smaller than that, yeah. There are some hit all the time, but they're much smaller. Have you ever seen a shooting star?
Yeah.
That's like a little tiny piece of dust hitting the Earth. And it burns up and you can see a little streak.
That's so cute.
If the thing were bigger and it didn't burn up, you would see a fireball going all the way across the sky, and then it would hit. And you'd be like, uh-oh. So, some interesting stuff going on. Let's take a look at some of the asteroids we've visited. So we've sent a spaceship to some. This is a near-Earth asteroid called 433 Eros. And it's an asteroid that they flew a ship to it. They orbited it, taking a whole bunch of pictures of it. And then they landed on it. They landed the spacecraft on it just to see if they could do it. It slowed itself down, and the gravity of this thing pulled it in, and it landed on it. There's a little spaceship sitting on this asteroid right here.
How big is that one?
The asteroid?
Yeah.
It's big. I think it's 10, 20 kilometers, maybe bigger than that. We could look that up. Google how big is 433 Eros
Gotcha.
and see what it says.
How many kilometers is the video we just watched?
The one smashing into the Earth?
Yeah.
It said as big as Japan.
It's 33
So,
kilometers.
so maybe like 1,000 kilometers. 33 kilometers
Which
for this
is
one?
20.5 miles long.
So that's about twice as long as St. Simon.
It's about as big as Lake Tahoe.
There you go. That would hurt if it hit us, yeah. That would be an extinction event, is what they call that. Video footage of this probe landing on the planet. What's up, Mac?
So are the asteroids not all fiery like the one in the video was?
The only reason the asteroid in the video was fiery because it hit the Earth.
But like as it
There we
was
go.
moving towards the Earth?
Let me zoom in just a bit.
They only get fiery when they
This is
enter
a
the atmosphere.
simulation
Oh, okay.
of the shape model.
We're looking,
And that one only entered the atmosphere. The one in the video was so big that it only had touched the atmosphere for a second.
Mm-hmm.
The atmosphere didn't even take up the whole. Only part of it was in the atmosphere before it collided.
What would that look like from the ground? Like, just this huge rock, like, coming and
Yeah.
smashing into
Didn't
it?
they show you the shadow coming over the
Yes.
That would be so
Would that be
scary.
darker than an eclipse, you think?
180
Yeah.
the end of the
Oh
asteroid.
my.
Oh, cool. Love that.
You do the best job you can telling the thrusters exactly where you want it to go. There we go. And let me zoom in just a bit. Okay, so this is the simulation of the shape model.
we're looking at a very interesting area on the asteroid where we see, lots of evidence of regolith and infilling of craters, and it looks like we're really on course for the descent to the surface later on this afternoon.
This is a group of scientists trying to land this thing on the asteroid.
The initial timing adjustment was based on Doppler tracking from the Deep Space Network, comparing the actual Doppler shift achieved from the maneuver to the expected.
Now I'm going to take you up to the present time, if I can see the next view graph. In this view graph, you see there's the orbit of the Earth, and then there's the orbit of Eros, and you see that Eros stays outside the orbit of the Earth. This is good, where we want to be getting images, and we also want to be breaking it. And that is shown in the next view graph, which shows our descent profile. And you see this takes about 47 minutes if all these braking burns work properly. What this final descent looks like. And here's the spacecraft coming down to the asteroid. The thrusters are firing, and it's slowing down nicely.
They don't want it to
the
hit
solar
too
panels
hard.
are pointed to the sun. The high gain antenna is pointed towards the Earth, so we're getting high telemetry rates back at all the time. Here we're doing a little turn to reorient so that the right thrusters are firing at the proper times. And this shows the very end of that descent, where we're coming down about 500 meters above the surface, slowly coming in. And I guess I only hope that the landing is as good as it looks on this film. Very slight bounce. I think it might be a little bit harder than this. In actuality, this is the first time that any spacecraft has landed on a small body.
You get lucky. The highest resolution image is right on it. And down here, we see in the bottom, the mess that you see here is missing enough velocity to survive the touchdown. So this is going to play out probably for some time here this afternoon as we continue to track the signal and see if we...
So they did land that thing on the asteroid. There's a picture that they have of it almost on the asteroid. So it did land, and it's successful, and it's just sitting there. They can't fly away. They don't have enough fuel on the thing. So, even if our planet gets wiped out, there's evidence that we were here sitting on that asteroid. Here's the Gasparo, the one we saw at the beginning, Galileo saw. And here's a big asteroid called Ida, another one Galileo saw. And this asteroid has its own moon. That little moon there goes around this asteroid, around and around it. That little moon there is the size of the bridge that goes to Jekyll. You know that big old bridge? That's how big that is. So imagine being on that bridge. That's how big you'd be compared to this rock here. Yes?
If Earth got crushed by this asteroid, or not crushed, but had all this happen to it, would our moon lose its orbit with the Earth, or would it keep orbiting?
It would probably keep orbiting unless it was a real big asteroid.
Which one had, which asteroid had it land?
This one here, Eros.
Eros, okay.
That's a near-Earth asteroid. And if I'm not mistaken, these two are in the asteroid belt.
Wow.
And Galileo saw them on the way. I'm pretty sure. Here's another one called Matilda. Now, asteroid Matilda is really cool. It's a big rubble pile. When I say rubble pile, that looks like a single solid object. But the measurements show that it's way too light to be a single solid object. And what the scientists think it is, it's a rubble pile. Imagine a bunch of little tiny asteroids that all got pulled in to make one big looking block, but if you got close enough you would see their individual smaller units packed together by gravity, but not packed so hard together that they're stuck together. And so you can still see craters and stuff, because if something hits the rubble pile, it'll make a chunk out of it. But this is actually not one single unit. It is a rubble pile. Matilda, asteroid Matilda. So some asteroids are like one big rock, and some asteroids are rubble piles. Yes?
You said it was too light.
It's what?
You said that it's not. No, you said science said it was too light.
Too light. It wasn't. It's not heavy. It's not dense enough to be a rock.
How do they know that?
They can measure it by when the spacecraft goes by. They can see how much the gravity of this thing pulls on the spacecraft. and they can get a measure of its mass that way. So they know how heavy it is, and they know how big it is by how big it looks, the camera taking pictures of it. So they can figure out the density of the asteroid that way, how massive it is and how dense it is. And they know this cannot be a single rock, it's a big rubble pile. Now, different asteroids have different compositions. Some of them are made of metal. Those are your metallic asteroids. And the metallic asteroids are mostly iron and nickel. Some of them are made of just rock, or mostly rock. And those are just made of rocks, like granite and basalt are types of rocks. And then some of them are combination, and some of them are rubble piles. So they all have, there's a bunch of different types of asteroids out there. We're just getting an idea of the different kinds that are out there. Oh, and there's 1950 DA. That may hit the Earth on March 16th, 2880.
Oh, man.
It's a half a mile wide, and it's so big it would not burn up in our atmosphere. It would collide, and it would cause an explosion bigger than a nuclear bomb. So that could totally eliminate a city if it hit the land.
We're not talking about extinction though, right?
Wouldn't be an extinction event.
How much area you can hit water? Like a continent, maybe hit that continent?
Maybe if it hit,
Australia?
no, let's say us. If it hit us, it would probably wipe out us, Waycross, Savannah, and Jacksonville, just right around that area. It could be bad news. And it would probably blow a whole bunch of debris in the atmosphere that would go around and cover the Earth and make it cold for a few years, and things could get bad. We wouldn't want that thing to hit. So we may want to deflect that one. So we got to figure this out by 2880. But that's only one of them that's out there. We haven't discovered all the ones that are out there yet. We think we only know about 20% of the ones that are out there. So this is the most dangerous one we've found, but there may be more dangerous ones out there, so it's a good idea for us to keep looking. And this is what astronomers do. They put their telescopes, amateur astronomers find a lot of these. People with their own telescopes, they'll take a long exposure photograph, they'll see a streak going along, they will contact a big observatory and tell them they found a streak and where they were pointed. If they keep good, accurate records, then the big observatories can go look for them and find out. You might be the one that finds an Earth-crossing asteroid. There's a movie about that. Have y'all seen the movie about that?
Did you get rewarded for
Where a guy discovers an Earth-crossing asteroid. It's called... Oh, I thought I had it up here. Does somebody check it out?
Is it a true story?
No, it's a fictional story. I can't remember what it's called. It's called Deep Impact, I think. Deep Impact is a movie that's about a kid. He discovers, an amateur astronomer, he discovers an Earth-crossing asteroid.
Bless you, sir.
Thank you.
It hits the Earth, causes a bunch of mayhem. It's a good movie. So, read about asteroids. And that's it. Any more questions about asteroids?
So there could be an asteroid that's gonna hit the Earth today, and they just haven't found it.
Yep.
Well, would they see it if it was about it?
They might if they're looking. But what if they weren't looking?
Are they looking?
Some are looking and some aren't. But we aren't covering every bit of the sky all the time. So it might hit us when we're not looking. And then that would be it. But, you know what's on our side is, it's been 65 million years since we've had a real bad impact. And so what are the odds that one's going to hit tomorrow? Not very good if it's been 65 million years and we haven't had one.
Or we're overdue.
Probably not going to hit tomorrow, but it could.
Or we're overdue.
We might be overdue.
Today.
Could. But probably not.
But it's not.
So,
On that note.
that's it.